paper, but as I read the stuff that is up here, I'm going to be marking on these pictures. I'm just making my own. Okay, so I'm just going to put them off to the side here so I can read and mark at the same time. So when it tells us right here that opposite sides are parallel, and granted this is for the parallelogram, opposite sides are parallel, I'm going to put an arrow here and here, and I'm going to put two arrows here and here. So that's what it means if opposite sides are parallel. Top and bottom are parallel, left and right side are parallel, and arrows indicate parallel. Okay, the next thing it says is that opposite sides are congruent. So that means the top is congruent to the bottom. I'm going to give those each one tick mark. And then the left side is congruent to the right side, so I'm going to give those both two tick marks. So that's the first thing we know about a parallelogram. We actually talked about that part just yesterday. Top and bottom are parallel and congruent. Left and right side are parallel and congruent. Okay, so now to stuff that we didn't talk about yesterday. This one says that consecutive angles are supplementary, which means they add to be 180. So that means A and B, those are consecutive because they're next to each other, so those add to be 180. B and C, those are consecutive because they're next to each other, so those add to be 180. C and D add to be 180. D and A add to be 180. So if you want to write that on there somehow for yourself, you could do that. That A plus B is 180, B plus C is 180, C plus D is 180, and D plus A is 180. And technically it's the angles. So if you want to write that somewhere on here for yourself, you could. That angle A plus angle B equals 180. I don't know how much room you guys have. That angle B plus angle C makes up 180. Angle C plus angle D makes up 180. And angle D and angle A add together to be 180. I just don't know how much space you have. But if you can squeeze it in there somewhere. But those are called consecutive angles because they're next to each other. So your consecutive angles add to be 180 in a parallelogram. So if that's true for a parallelogram, it'll be true for the rhombus, it'll be true for the square, and it'll be true for the rectangle because those are all parallelograms. Okay, the next thing it says is that alternate interior angles are congruent. I'm going to come back to that one. I want to go to the next one. This one says opposite angles are congruent. So in this picture, what do you think is the angle opposite angle A? Okay, so opposite angles are congruent, so A and C are congruent. I'm going to give them each one curve. And then B would be congruent with D, so I'm going to give them each two curves. So in a parallelogram, your opposite angles are congruent, so B and D are congruent, A and C are congruent. And then the consecutive ones add to be 180. Okay. I'm going to go to the other picture to talk about the alternate interior angles being congruent. So we already know that these two sides here are parallel, and if these two sides are parallel, then these are alternate interior angles, which means they must be congruent. And then if these two sides are parallel, these are also alternate interior angles, so they're going to be congruent. But that doesn't mean they're all for the same thing. It means that these two will be the same and these two will be the same, but they're not all for the same in a parallelogram. Mason, you're not paying a lick of attention. You do not. You have these little curves I just drew? No, you don't. Why do you lie to me? Don't lie to me. I can see, I saw from here there were no curves on your paper. My point is you haven't made these curves, and you said you had. Okay, these guys right here, they're alternate interior angles, so they're congruent. I'm going to give them three curves. And then these two right here, they're alternate interior angles, so they're congruent. So I'm going to give them four curves. So that's kind of messy. So since it's a parallelogram, we know the sides are parallel, which means that these are alternate interior angles. Same thing, those are alternate interior angles, and alternate interior angles are congruent. And then there's one other thing on here. It says that the diagonals bisect each other. What's that mean to you? Yeah, they cut each other in half, and they do meet at that middle, but they hi-ya each other. They cut each other in half. So when this one cuts this one in half, it cuts it into this piece equaling this piece, if you can see my little red tick marks. So this piece equals this piece, and then when this one chops this one in half, oops, sorry, I did that wrong. When this one chops this one in half, it makes this piece here equal to this piece. So I'm going to give this one 2 tick marks and this one 2 tick marks. So that's what it means if diagonals bisect each other. So they chop each other in half. So this piece of the diagonal equals this piece, and this piece equals this piece. Okay, that's the parallelogram. So now I want to do the examples that I had you guys put on here yesterday. So hopefully everybody put them on here. I obviously don't have them on mine because I'm going to do them on the paper. But yesterday I wanted you to put 5 examples down here. And they came from your 6-2 notes. So if you didn't put them down there, you'll need to do that. I'm going to work them on the actual paper. And then you guys can just put them in your foldable. Is there anybody that didn't get them on the foldable yesterday? Okay. How about you, Dakota?
What?
Where's your foldable? Where's your notes? Where's your stuff? All I see is your phone. Okay, on number 1, we learned several things just a minute ago. What did we learn about opposite angles? No. Diagonals cut each other in half. Opposite angles are congruent. And if you can't remember, that's the whole point of the foldable. It tells you right here that opposite angles are congruent. So that means that these 2 angles are congruent, so y would be 62. Okay, then it tells you something about these guys. These guys are called consecutive angles. What's it tell you about consecutive angles? They're supplementary. They add to be 180. So if these 2 add to be 180, can somebody tell me what x is? 118. Okay, and what kind of angles would you call x and z? Opposite or consecutive? They're opposite, and opposite angles are congruent. So x and z will be the same, so z is 118. And it is a lot to remember, especially once you've learned about all the shapes. So that's the whole point of the foldable. If you don't remember about the parallelogram in particular, you just look, and it tells you opposite angles are congruent, consecutive angles are supplementary. So it's all right here. Okay, number 2. Can anybody tell me what x is without me saying anything?
38.
X is 38. Beautiful. Because this is a parallelogram, these guys are alternate interior angles. Does anybody know what y would be?
48.
48.
Oh, sorry.
32. How are you getting your 32?
That's equal 180.
There we go. This is a triangle, right? And what do the 3 angles in a triangle add to be? 180. So these 3 angles need to add to be 180. So if you add those 2, you get 148. And so what'd you say this would be? 32. So y is 32. Okay, and z? 110. And how did you know z was 110? Opposite angles. Beautiful. The z and the 110 are opposite angles, and opposite angles are always congruent. Very nice. Okay, let's look at the third one. Let's skip x for a second. Can anybody tell me what y is? Y is 28, because those are alternate interior angles, so those are congruent. How about z? Z is 71, because the 71 and the z, those are alternate interior angles, so they're congruent. Okay, take a moment and see if you can calculate x for me. And what'd you get?
Once you add 71 and 28,
Yep. It should be 81. So I've got this triangle going on right here. So you told me a minute ago that y was 28. So you would add the 71 and 28 and take that away from 180, and that will give you x, which is 81. So that's exactly what that is. Okay, number 4. This one looks a little funky. Can anybody tell me what to do to find x? This is from our past.
What? Subtract 85 from 180?
Yes, we're going to subtract 85 from 180. Everybody see this straight line right here? So from here to here, that's 180 degrees. So what do we get if we take 180 minus 85? 95. Okay. And now that you know x is 95, we can find y because this is a triangle, and these 3 angles need to add to be 180. So if you add the 95 and the 48, and then take that away from 180, can anybody tell me what y would be? 37. And then if y is 37, how about z? Z is 37, because the y and the z are alternate interior angles, and alternate interior angles are congruent. So a little bit of some old mixed in with some new. Okay, number 5, let's start with x. When you look at the 71 and the x, are these opposite angles or consecutive? Consecutive. Are consecutive supplementary or consecutive congruent? Supplementary. Consecutive angles are supplementary. So what would x be then? 109? Okay. And then let's talk about y. So what should this angle right here be? The whole thing. It should be 109. If x is 109, this whole angle should be 109. So what do you think you could do to figure out what y is? And if we set up an equation, I could say y plus 21 equals 109. If I wanted to set up an equation. And then you would just subtract your 21 from your 109. And what do you get if you subtract 21 from 109? 88. So once we figured out what x is, this angle down here is the same because those are opposite angles. So the y plus 21 has to be 109. If this angle is 71, what's this angle right here? 71. So that means z minus 5 has to equal 71. So z would be 76. Okay, so now you have a few concrete examples on your foldable that kind of give you some examples about opposite angles and consecutive angles and a little bit more. Okay, so that's all we're going to do on the foldable today. So now I'm going to do some problems that are just in the notes. Okay, so just looking in our 6-2 notes. So hopefully everybody has those out. In the 6-2 notes, let's go to page 3. Okay, and I want you, since we've already talked about this a little bit, to do number 1 and to do number 2 real quick, and then I'm going to draw 2 sticks. So on number 1, you're finding the measure of angle S, and on number 2, you're finding the measure of angle O. So take a second and do that, and then I'm going to draw 2 sticks. Okay. We put some stuff in the foldable, Delaney, and I've already taught a little bit. Jake, you're my first one. What did you get on number 1 for the measure of angle S? You got what? You got, I didn't understand your name. You got T. Okay, so what's angle T?
112.
Okay, 112. Okay, so Jake, my question is, S and R, would you call those opposite angles or consecutive angles? Opposite are R and T. Opposite are S and W. So S and R are consecutive because they're next to each other. Consecutive numbers are like 1, 2, 3, 4. They're like next to each other. So these are consecutive angles. And what's the foldable tell you about consecutive angles? Are they congruent or are they supplementary? And it actually tells us actually at the top of the page too.
Consecutive.
Consecutive angles are supplementary. So I would take 180 minus 112. Can anybody tell me what that is? 68. And just to finish it, if S is 68, what's W? 68. So I've got the same notes on here too. I just had us put it in the foldable so it's just in one spot and you don't have to go hunting all over the place. So here it tells you up here that consecutive angles are supplementary. So these two are supplementary, these two are supplementary, these two are supplementary, and these two are supplementary. But then opposite ones, those are congruent. Okay, and then number 2 goes to Natalie. What'd you get for the measure of angle O? 145. Good. Q and O are consecutive angles, so that means that they're supplementary. Can you guys tell me what angle K is? 145. It's opposite with O, so they're congruent. And how about M? 35. It's opposite with Q, so those are congruent. Okay, let's hop down, and I want everybody to do number 5, and then I'm going to draw 3 more sticks. So down at the very bottom there, do number 5, and then I'm going to draw 3 more sticks. Okay, Brooke, you're my first one. What'd you get for X?
68.
68. Beautiful. The 68 and 112 are consecutive, so they have to be supplementary. Kim, how about Y? It's 112 because these are opposite angles and they're congruent. Beautiful. And Cormac, Z?
I got 68.
68. Good. It's opposite with the X, so they're congruent. So, in a parallelogram, you feel good about opposite angles and consecutive angles? Okay, let's do these 2 above, and then we're going to look at some problems that are going to be a little bit of a review from Algebra 1, and maybe MMA if you came from there. Okay, in number 3, I have a couple different things I need to find. So I'm going to focus on the ones with the X's. When you see the 3x minus 15, is this an angle or a side? It's a side, and the 2x plus 3, angle or a side? What do you know about these sides? They're parallel and congruent. So in a parallelogram, your opposite sides are parallel and your opposite sides are congruent. So I know that this segment QR is congruent to this segment PS. So what would your equation be? Good. 3x minus 15 equals 2x plus 3. And then whenever you have x's on opposite sides, you need to get them on the same side. So I'm going to move the 2x. How does he go? Subtract him. So I'm going to subtract 2x from both sides. And then how much is 3x minus 2x? 1x. I'm going to bring down the minus 15, the equals, and the 3. And x would then be 18. Okay, now you'll notice that it never asks for x in the directions. It asks for the length of PS. So what would I do to find the length of PS? Plug it in. So I'm going to put that 18 right there into that x. And then how much is 2 times 18? And 36 plus 3? 39. So PS has a length of 39. So be very careful, because I know on our final exam that you guys took first semester that happened quite a bit. That sometimes you would stop when you got your X answer, but then you weren't quite finished. Okay, now let's go to the Y's. Are these guys angles or are they sides? They're angles. Now, are they opposite angles or consecutive angles? So are they congruent or supplementary? Supplementary. So what's the equation? There we go. So 6y plus 5 plus 10y minus 1 equals 180. And then I'm just going to work it out. This time I have like terms on the same side of the equals, so I can combine them. So what do you get when you combine your 6y and 10y? 16y. And then what do you get when you combine your positive 5 and your negative 1? Positive 4. Good. And then to remove the 4, you would subtract. If you subtract the 4, I'm not going to show it, but what do you get if you subtract the 4? 176, and then you would divide by 16, and can anybody tell me what that is? 11. Now, in the problem, does it ever ask for y? No, it asks for the measure of angle r. So we're going to plug it in. So if I put the 11 into the y, what's 11 times 6? And 66 plus 5? 71. So the measure of angle R is 71 degrees. And then once you know one of the angles, then the others are really easy to find. Okay, on number 4, these guys right here, are they sides or are they angles? Angles. Are they opposite angles or consecutive angles? Opposite angles. Are opposite angles congruent or supplementary? Congruent. So what's the equation? Okay, so x plus 15 equals 135 minus x. Okay, you guys take a second and solve that for x. I'm going to draw a stick, and then we'll go from there. And are you guys ready? Okay, and this one goes to Harris. Harris, what'd you get for your x?
60.
60. Yep. So you could move the minus x by adding it. That would be 2x plus 15 is 135. If you subtracted the 15, you'd get 120. And if you divide by 2, you get 60. Now, what did they ask for? Okay, they asked for the measure of angle A, but they didn't give us angle A for us to just plug that in, so I have to put this somewhere else. It's your choice. Where do you want to put it? Where does it look easier to put? Okay, it looks easier to put into angle B. So if I put 60 into that x, what's 60 plus 15? So if angle B is 75 degrees, what would angle A be? 105, because those are consecutive angles, and consecutive angles are supplementary, and that would be the measure of angle A. Very nice. Okay, the next page is a little blast from the past. So, first, let's talk about what the diagonals do to each other again. The diagonals bisect each other, which means they chop each other in half. So, HE is congruent to ES, TE is congruent to EG. So whenever you have a parallelogram, the diagonals will bisect each other. They'll chop each other in half. So that means that's true for the square, it's true for the rectangle, it's true for the rhombus, because those are all parallelograms. Okay, so knowing that, when I look at number 1, this symbol right here, because I haven't really stressed it, but this symbol right here does mean parallelogram. So it's telling me that this is a parallelogram, and it wants to know x and y. So I want to hear some equations. Can anybody give me an equation that you know? 2x plus 5 equals 5y. Let me write it down. 2x plus 5 equals 5y. So I know this diagonal gets chopped in half by ln, so 2x plus 5 equals 5y. The problem is I can't solve this because it's one equation, two variables. Can't solve it. What's the other equation?
7y minus 16 equals x.
Yep, 7y minus 16 equals x, because this diagonal gets chopped in half too. So 7y minus 16 equals x. There's this thing called substitution you would have learned about in Algebra 1. You would have done it in MMA as well. There's different ways of solving systems. This is a system of equations here. A system of equations. You've got two equations with two variables. There's a method called substitution, and I know in Algebra 1 last year they talked about bread meat bread.
What?
Did anybody, does it, that? Okay, so I'm not going to do the bread meat bread the way it looks. I'm going to do it a little different this year, but I know that that's how some people did it in Algebra 1. There's also elimination, there's also graphing, and then there's matrices that you can do in your calculator. But if you ever have a variable all by its little lump sum, substitution is the one you want to use. I'm just not going to set it up in that bread meat bread organizational system that they had you do in Algebra 1. So if you have no clue what I'm talking about, then it doesn't matter. If you do recognize what I'm saying, I'm just going to do it a different way, but it's the same idea. So with substitution, you want a variable all by himself, and as long as he is, you're ready to plug in. So if this is what x equals, where do you think I can put it in the other equation? Into the x. So this top equation now, instead of being 2 times x, it's going to be 2 times 7y minus 16, because that's what x equals, and I'm substituting 7y minus 16 into that x. And then I have to recopy the plus 5, and I have to recopy the equals 5y. Do you guys remember doing substitution? Okay, so the bread meat bread did the same thing, it just looked different. Okay, so now I just have to work this equation. You can see this equation only has y's, so you can actually solve. So what do you get when you distribute the 2? 14y minus 32. I'm going to recopy the plus 5 and the equals 5y. Okay, and then from here, I can combine the negative 32 and the positive 5, and that would make what? Negative 27. Okay, so I've got 14y minus 27 equals 5y. And then I need to get those y's on the same side. So I typically move the smaller one, but since 5y is all by himself, there's no constant added or subtracted to it, I'm leaving him alone. I'm going to move the 14y. How can I move the 14y? Subtract it. So since it's a positive 14y, I'm going to subtract it. The minus 27 would drop, the equals would drop, and what do you get if you take 5y minus 14y? A negative 9y. And then you would divide both sides by negative 9, and that's going to make y equal 3. Okay, but notice there's an x and there's a y. So now I need to plug this 3 back into a y. Quite honestly, it doesn't matter which y I put it back into, but the easiest place to put it is the equation where you had the variable by itself to begin with. So I am going to put the 3 back in this equation, and he's going to go into this y. So what's 7 times 3? 21, and 21 minus 16? 5, and that's your x. Do you remember it? So there's substitution, there's elimination, there's graphing, and then there's matrices. And they're all ways of solving systems. But if you ever have a variable already by itself, substitution is probably the easiest one. Okay, so number 2. I need some equations. Once again, I have a parallelogram, so diagonals bisect each other. Hi-ya! So give me an equation. X plus 1 equals y. Good, because that diagonal gets chopped into 2 pieces. Once again, I can't solve it because it's one equation, 2 letters. Give me the other equation. Good. 3y minus 7 equals 2x, because this diagonal gets chopped into equal pieces too. Okay, so then you want to look to see if you have a variable by itself, and you do. Y is by himself, so this is the equation I'm going to be working with. If this is what y equals right here, where am I going to put it in the other equation? Into the y. Okay, so now it's going to be 3 times what? X plus 1. Good. Since that's what y equals, we're just substituting that into the y. I recopy the minus 7 and the equals 2x. Now you have an equation that has nothing but x's, so you can actually solve. Okay, what do we get if we distribute the 3? 3x plus 3. I'm going to recopy the minus 7 and the equals 2x. I can combine the positive 3 and the negative 7, and that would make negative 4. So I've got 3x minus 4 equaling to 2x. Okay, I'm going to move my 3x just because the 2x is already by his lonesome over here. So how do you move the 3x? Subtract it. If I subtract the 3x, I'm going to get a negative 4 equal to a negative x, so that means x is 4. X is a positive 4. So there's my x, and then I need to find my y. Can anybody tell me without me showing you? 5. I would go back to the equation where I had my letter by itself. I'm going to put the 4 in that x, and 4 plus 1 is 5, so y is 5. You feel like you understand? Okay, do you want to do more, or do you want to have some time to work on the worksheet I gave you yesterday? Okay, so hopefully everybody still has it, and I do want you to do the whole thing. So somewhere on there, there should be hopefully a problem like this. If there's not, I'll be annoyed with myself.